Let's say you're given this kind of problem which says the period t of a simple pendulum is measured in time unit and is given by t, which is going to be 2 pi the square root of L divided by G. Notice that the L simply stands for length of the pendulum and G is the acceleration due to gravity in units of length divided by the square of time. So what we are asking in this problem is to simply show that the equation is dimensionally consistent. So how can we solve this problem? Notice that to show that the equation for the period t of a simple pendulum is dimensionally consistent, we simply need to verify both sides of the equation to be the same or to be the same dimensions. So the equation which we are given, we said is time, basically is a single equation which is time 2 pi into L divided by G. Let's consider this side to be our, let's say, left hand side, and this side should be our right hand side. So for it to be dimensionally consistent, both the left hand side and the right hand side has to be the same. A quick review again. We said the L simply stands for the length of the pendulum, and here is acceleration due to gravity, right? And here is the time period. So first thing which we need to do in order to carry out this problem is to identify the dimension of each variable, starting with the first one, which is t. Notice that the dimension of time is denoted as t. Let's put it in bracket to show that it is a dimension. What about the dimension of length? Notice that the dimension of length is denoted as L. And here comes the dimension of acceleration due to gravity, which is G. Here it comes as L divided by t to the power of 2, which is the same thing as saying Lt minus 2. So what are we going to do next? Now, the next thing which we are going to do is to analyze the right hand side of the equation. This is where the problem is, isn't it? So, but before then, what do we have in the right hand side of the equation, which is 2 pi into square root of L divided by G. So the first thing which you are going to encounter here is the 2 pi. And notice that 2 pi is dimensionless, a constant. So we can just forget about it and express the one inside the square root. And what we have in the square root is the square root of L divided by G. So what is the dimension of length? We said we denote the dimension of length as L. What about G, which is acceleration due to gravity, which is L divided by t to the power of 2, which is the same thing as saying t minus 2. In this case, notice that here is going to be t minus 2. Sorry, I want to write Lt minus 2. Lt minus 2. What if the length cancel out? This is going to be the division of t minus 2. And what if we take it upward? We are going to neglect the negative sign, which is simply going to be t to the power of 2. So at this point, next thing which we need to do is to take out the square root. So notice that we are going to bring this one down, which is going to be the square root of L divided by G is simply going to be the square root into the dimension of t to the power of 2. And notice that this 2 will cancel out. What are you going to be left with? It's going to be the square root of L divided by G, which is going to be t. If I'm not mistaken, this is our right hand side, which is this. And here we end up with t, which is what we have at this point. So, next thing which we need to do after comparison, you find out that both of them are the same, which is t. Both right hand side is t and left hand side also is t. So we can finally conclude and say, since both sides of the equation have the same dimension, which is t, the equation is dimensionally consistent. So this is it for this problem. I hope you find it helpful. If you do, please don't forget to click on the subscription button at Geminic Science. Thank you. Let's say you're given